Hi guys, BuildZoid here, and today we're going to be taking a look at the Asrock 990FX Extreme 9 motherboard. And you might be like, BuildZoid, why the hell are we looking at this? And it's just like, because I like the AM3 Plus platform. And now you might be like, but BuildZoid, why the hell do you like the AM3 Plus platform? It's simple. Very simple. It's cheap. It has a lot of different CPUs. They're very overclockable. And that's basically it. So what do I mean by the very overclockable? So here's the thing. So AM3 Plus, you buy one motherboard, right? And assuming the motherboard is good, you can run Athlons, you can run Semprons, you can run Phenom 2s, you can run FX CPUs. So you've had a huge variety of CPUs that you can play with, which is really cool. Anything from, like, you can play with things like you can get triple core CPUs and pentacore CPUs, right? Like some really kind of weird niche CPUs are available for the platform, which is pretty neat. Then all of the CPUs are actually kind of ridiculously overclockable because you can do BCL, like you have BCLK overclocking where you have quite a lot of range. It varies motherboard to motherboard, but with a lot of 990FX boards, you'll be able to go over 300 BCLK, which is a 50% overclock without even changing any multipliers, which basically means even if you have a CPU that's locked, you can still do a decent amount of overclocking with it. Admittedly, there are other, there are platform, like if you want to really push something like a Sempron 145, there are motherboards that are actually better for it on like older chipsets. I think on DDR2, there's a platform that goes up to like way more BCLK than 990FX generally does, but, you know, not really. Like I mostly like the platform for the Phenom 2s and the FX CPUs, because the thing is, so with the Phenom 2s and the FX CPUs, so yeah, you've got your core overclocking, BCLK overclocking, memory clock, Northbridge clock, hyper transport clock, right? You've got all of these different things that you can overclock on the platform. But also, with the Phenom 2s specifically, right, you can unlock cores, so you can get like a dual core, unlock it into a triple core. You can also buy a triple core unlock to a quad. You can buy some quad cores unlock to pentacores, right? So or even 6 cores. You've also got the fact that the CPUs are generally, well, so Phenom 2s I don't think are anywhere near as robust in terms of voltage as the FX chips, but the FX chips are tanks. Like, sure, they pull ridiculous amounts of power. They're not actually that hard to cool because they're relatively low thermal density. But they're like, the thing is, you can shove insane amounts of voltage into them, which, like if you want, you can run, like, if you have a big enough water cooling loop, you can actually bench at like 1.65 volts. And the CPUs won't up and die immediately, like won't start rapidly degrading on you, which just makes the platform really, really fun. And then it's just like, and not only do you have these really high voltage tolerances, you can also go through a lot of CPUs. And so I really like the AM3 Plus platform because of that, because you've got a lot of cheap, very overclockable CPUs. And now the only problem with the platform is getting good motherboards. And there's not that many good motherboards for the platform because the CPUs weren't really competitive in terms of actual performance. Sure, they're fun, like FX chips are great fun to overclock, but let's be honest, they're slow. Like, no matter how many gigahertz you get out of an FX, they still kind of suck. And so the problem with the platform is you don't really have a lot of choice in terms of high-end motherboards, which is why I picked one of these up on eBay, even though it's in kind of terrible condition. Apparently the audio doesn't work. There's a clip missing down here, which, to be fair, I often remove my own, like I often remove the PCIe clips on my motherboards myself, so I don't really see a problem with that. Evidently somebody decided to try plug a Delta fan into this because they blew up the fan header power trace going to that fan header over there. So yeah, this motherboard's pretty beaten up, but at the end of the day, you know, if you're looking for an AM3 Plus motherboard and you want a postcode, power button, reset button, and also, well, the thing is it doesn't have dual BIOS, but at least the BIOS chip is socketed, you don't really have that many options, right? Like, it's a real problem with this platform. There really aren't that many options for a motherboard with these features. There's this board, There's the Gigabyte Ultra Durable 7. There's the Crosshair Crosshair V Formula and the Crosshair V Formula -Z. There's an actual significant difference between those. I personally would rather have a Formula than the Formula -Z because the Formula -Z removes a bunch of core control features from the BIOS for no apparent reason. There's this thing, right, with the postcode, and then there's also, like, Gigabyte has the G990FX G1 Gaming that also has a postcode. And I think I just listed off every single board with a postcode on the platform. So if you're looking for, and some of them don't have that great, for example, the G1 Gaming really isn't exactly spectacular in the VRM department. It's good enough, okay? Like, I really like it for, say, Phenom 2 overclocking, but when I tried to run a overclocked 8-core on liquid nitrogen on it, the VRM kept shutting down on me because, there's an overcurrent limit. Of course there is, right? So anyway, so the problem is just like, and a lot of these motherboards are pretty expensive, so they weren't really popular, right? The crosshairs are actually quite common. Sabertooth motherboards are also pretty common because those were the boards that had a reputation for, like, actually being really solid and high quality in terms of build. And then this came out, and this is actually, if I remember correctly, or at least I remember when this came out, this was more expensive than a Crosshair V Formula Z. So this, I expect, was super unpopular, which I think makes this rather rare. I've certainly not seen a lot of, like, there's not really a lot of high scores with this motherboard on a hardware bot with it, so it does seem to be pretty rare, at least among overclockers, because most people will just get a Crosshair instead, because let's be honest, most people would rather just have a motherboard that they know is good rather than taking a chance with this thing. And like, I totally understand. It's just that I really, like, for me, AHOC is not just about the overclocking. It's also like I just like interesting hardware and rare hardware and weird hardware. And so this kind of qualifies for the, this is interesting because it's the flagship from Asrock for 990FX, right? One of the few motherboards where it's just like, well, you got one hell of a VRM. So let's talk about that VRM. So that's why I picked it up, right? It's just flagship motherboard, not necessarily the best. Like, it might not be the best board on the platform, but at the same time, I just kind of find it interesting, and the platform is fun to overclock, and I'd like to have more, like, because I actually have two other boards. Like, I have the 990FX G1 Gaming from Gigabyte, and I really like that board, but the VRM is just not that great. And then I also have a 970 Aura from Asus, and I used to have a Sabertooth, but that thing up and died on me, which they tend to randomly do. And the 970 Aura is also a solid board. It's just that it doesn't have a postcode or power buttons or anything, so that one's kind of not that fun to work with. The G1 Gaming, the VRM is not strong enough. Also, the Aura is missing some of the core control features because all of the later Asus motherboards just removed those, which is really annoying. But this, as far as I know, actually has, like, the same set of core unlocking and disable features as, say, the Gigabyte boards, but VRM. We got a VRM here. Now, the BIOS on this thing is exceptionally clunky, so Asrock BIOS experience for you. But at the end of the day, it's just like, yeah, if the VRM makes up for it, I'm willing to live with the clunky BIOS, right? And actually, I'm kind of toying with the idea of kind of upgrading the board because we'll see. Once we get to the back of the board, you'll see exactly why I'm kind of thinking about, hey, maybe it could do with some extra capacitors. Anyway, so let's talk about the VRM. So this top part up here, that's the CPU NB. That's a two-phase. And then the rest of this VRM looks like, oh, look, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this looks like a 12-phase, except it's a 6. Because of course it's a 6. This is ASRock. Like, what did you expect? So I'm actually not sure why they went for this, because technically they could have just gone with IR3598 dual drivers instead of just CHL 8515s, which is what they ended up with. So that's these. Well, no, they could have gone with 3598s. Like, they would have actually had less chips behind the board if they just went with, well, no, they'd get rid of one of the extra CHL 8515s. But so these chips right here, all of them are CHL 8515s, and these are basically weaker 8510s. So it's just a single phase driver, and that's all there really is to those. And yeah, so you basically get two dual NFETs. That's these chips. You get two dual NFETs and two inductors in each phase. So a phase looks like that here. And each dual NFET has a high side MOSFET and a low side MOSFET. And then of course you have a high side and another low side down here. So yeah, that's the control scheme here. It's just like, it's just a straight up 6+2 phase. The controller is a CHL 8328. Which is running in 6+2 phase mode, of course, because that's what we have, 6 and 2 up here. This is actually a pretty nice controller by AM3 Plus motherboard standards. There's a lot of other motherboards which would go for, say, like a 4-phase, no. 6-phase controller instead of an outright 8-phase, and then use doublers to get like an 8-phase V-core. So this is actually a bit better than like this could actually have a significant advantage over a lot of motherboards, even in like the voltage regulation department. So I do actually want to do some oscilloscope measurements on the AM3 Plus platform, because it's just like, well, the motherboards are cheap and the CPUs are cheap, so it'll be like, you know, I'm just interested, like, and it's a fun platform to overclock, and it would be really cool to just see like what are the best like LLC settings and what's the best approach to setting the voltages and doing everything. So anyway, so you have the 8328, and this is basically a 8318 controller, which that's like, at the time, this was basically one of the, well, the 8318 was for like a older spec of Intel voltage regulator and NVIDIA GPUs. You actually see the 8318 on a lot of newer NVIDIA GPUs as like, well, yeah, like this chip is actually kind of rare is what I'm getting at, because it's basically a CHL 8318, but built with support for the, support for AMD CPUs and like a newer spec of the Intel voltage regulator. So not a very common controller. It is an 8-phase, which is high-end, but, you know, at the time that was a pretty high-end controller, and it also goes 200 kilohertz all the way up to 1.2 megahertz switching frequency. So, yeah, and this frequency at the frequency range at the time was actually pretty high. Well, no, by the time this board came out, I think you could get controllers from IR that go up to 2 megahertz, but, like, they weren't particularly popular. So, yeah, bit of an interesting controller there. Anyway, the actual dual NFETs we're looking at are CSD 87350s, which are like some pretty serious dual NFETs, right? These are very popular with high-end motherboards for a long time now. Like, you can find these on a Rampage 4 Extreme. You can find them on the Rampage 4 Extreme uses them. Maximus 9 Apex used them. Like, there's a bunch, like tons and tons of motherboards use these, and I guess it makes sense because these are relatively cheap because they're dual NFETs, and they are quite powerful, as they are, like, Texas Instruments specs them as a 40 amp power block, which you wouldn't actually want to run 40 amps through them just because they produce quite a lot of heat at that point, but they are quite efficient. And so they can handle a lot of power. They're basically a cheaper alternative to something like an IR3553. And unlike an IR3553, you can put two of them in parallel without any of the sort of like weirdness of running two power stages in parallel, which is a little bit more awkward to deal with. So yeah, that's why these are probably so as popular as they are, because it's just like, yeah, if you don't actually want to have a lot of phases, you just put two of these in parallel, bam, you got twice as much current handling capacity, right? Like, this basically makes it a 80 amp phase, quote, you know, in quotes, because again, you don't really want to be pushing 40 amps through them, but within the rating schemes of, you know, like power stages and power blocks that come with actual current like current recommendations. Yeah, like this kind of works out as like an 80 amp phase. Anyway, what this means for the efficiency is that it's actually pretty good. So I'm actually really like, yeah, like this motherboard is basically a lot of VRM for the AM3 Plus platform, which is kind of hard to find, even though the AM3 Plus, like the AM3 Plus CPUs, right, quite power hungry, not actually that high current. If you think about it, because they run at relatively high voltages. Like, if you were overclocking an FX chip, you'd probably be at like 1.5 volts V-core. Like, you'd be setting up to, say, 1.5 volts V-core, or even 1.55. And then if you were benching, like, I've benched up to 1.7. Like this is just like on water cooling. It's hella hard to cool at that point, but the chips don't up and die on you, so why the hell not? So yeah, 1.3 volts, 500 kilohertz switching frequency, which is just like, this is a convenience thing. That's what the data sheet is spec'd in. So this is a bit low, but 5 volts gate to source voltage, which is just, what's recommended to run these dual NFETs. You might actually find some advantages with overvolting them a little bit, because it can lower the RDS on over the low side MOSFET. Which can lead to some efficiency improvements, depending on just how much current you're trying to run through the VRM. But there's very few motherboards that actually take advantage of like I think this controller does support variable gate drive. I'd be very surprised if it didn't, because it was a pretty standard feature for CHL controllers. To have basically you'd have a little mini buck converter to provide the actual driving voltage for all of your MOSFETs. But on most motherboards, especially like a motherboard like this, sure, it's the most expensive, one of the most expensive AM3 Plus boards ever. That doesn't change the fact that AM3 Plus motherboards really didn't have that high a max price point. So doing fancy things like variable gate drive, not within the, budget for these kinds of boards. So you just run it off of 5 volts, because you can get 5 volts straight, right off of your 24 pin. Anyway, so at these operating parameters, the VRM would be capable of pushing 100 amps while producing 12 watts of heat, which is great, right? Like that's actually that with how much surface area this VRM has, just by nature of being this many this many MOSFETs. This is actually really this would probably be able to run without a heatsink at that kind of current output, though the heatsink is combined with the Northbridge heatsink, so you can't really you wouldn't actually you can't really do that because the Northbridge needs cooling. But the VRM itself is pretty efficient at 100 amps output. At 200 amps output, it's still pretty good. Definitely 26 watts is far from the hottest VRM on the AM3 Plus platform, because don't forget there's a lot of AM3 Plus motherboards which are literally a 4-phase with terrible MOSFETs. It's not a good thing. Anyway, 200 amps, 26 watts. Okay, at this point you might need some airflow over the VRM, but it's really not the end of the world. You might actually even be able to get away without any airflow. Really depends on how well the heatsink on the motherboard works. But Asrock does have I love this thing. This is literally just an airflow restrictor, right? You cut all of these fins into your heatsink, and then you make absolutely certain no airflow can get through it. They have one of these lovely airflow restrictors over the Northbridge heatsink and over the VRM heatsink. So yeah, I'm not really sure how well the heatsink will work, but maybe if you remove the airflow restrictor, this might actually be doable passive. But anyway, so 200 amps output, which is actually if you're doing just kind of ambient benching, this is around the max current you'll really ever see, because again, at 1.5 volts, this is 300 watts. Right, and yes, the FX chips are famous for being very power hungry, but there's other power hungry things on the platform, like the CPU Northbridge, and then the motherboard Northbridge, and then of course you have your memory sticks and your chipset, and so the whole platform in general is just inefficient, because this thing sucks up a whole bunch of power. Right, that's the 990FX motherboards, their idle power consumption really kind of sucks because of this thing right here. There's just nothing you can do about it. It pulls a bunch of power. So, yeah. Anyway, where was I going? So yeah, 200 amps output, decent, not ridiculous amounts of heat being produced. 300 amps output. At this point, the VRM starts to actually, you're going to need some serious airflow at this point. But at the same time, 300 amps, you're probably only ever going to see that on LN2 while benching the 8-core CPUs. So not really that big a deal. And then 400 amps output, which is mostly just hey, what if you went just for fun figure kind of thing? The VRM would produce about 78 watts of heat. So at this point, water cooling, the water cooling the VRM would make sense. Though realistically, you're not going to be able to go much past that 300 amp current draw figure. Even if you're on liquid nitrogen, you really won't be getting past that, because consider this. If you're benching FX CPUs, you would very easily be around the 1.8 volts mark. 1.8 volts at 300 amps, you're looking at 600 watts going into the CPU. Which actually I don't think I don't think they do 600 watts. If I'm not mistaken, because that's the thing is like if you're very like if you're far below zero, your current draw actually decreases quite a lot. So, 1.8 volts at like ambient temperatures, yeah, you're going to pull absolutely insane amounts of current. But 1.8 volts at minus 196, which that's the other thing that I really like about the AM3 Plus platform. Basically, all of the CPUs that you can install in this socket are cold bug free. So you can arguably bench them without a thermometer. I wouldn't recommend it, but you could it's not going to be as hard as like say some of the Intel platforms where it's just like if you don't have the thermometer, it's just going to like lock up on you and you're going to be screwed. So yeah, with the FX platform, like you literally don't even need to check your LN2 pot temperatures because the chips run full pot. But yeah, so at full pot, the current draw is actually not going to be as high as it would be if you were at much like warmer temperatures. So yeah, the VRM here is like this VRM is probably just why the board is so expensive, because really the rest of the motherboard is not that impressive. But the V-Core VRM certainly is. And, they also added things like tantalum capacitors to the output filtering, which these do drive up, like these are pretty expensive. Compared to your standard through holes, you're looking at, 2 to 3 times the cost of your through hole capacitors. So yeah, they are much more expensive. Also, you might be looking at these capacitors and going like, oh, they're golden, does that mean anything? No, it doesn't. It's just like a color option. If you buy enough capacitors from a capacitor manufacturer, you can ask them to be pink. I'm sure they'll happily oblige you, like right, like it's just kind of an option. So, and that's like these days, all of the capacitors on all motherboards are black. I kind of miss having colored capacitors, right? Because if you're actually buying capacitors like normal bulk from any electronics component supplier, they're going to be just metal colored with the like a red or a blue stripe or maybe a purple stripe to indicate which side is ground, like which side is the negative end. So yeah, like I know a lot of people would be like, oh, but that's going to mess up the aesthetic, but I like my silver and red capacitors. Like I really do. But yeah, like and the gold ones, honestly, not that bad. They're nice, like they don't do anything, but I find them more interesting to look at than the usual blackout motherboards we get today. It's a shame that the PCB is brown though. Like that I'm not a fan of. If this was a red PCB, that would be sick though. I wish we had red PCB motherboards. Well, we can't have that in an RGB world because everything has to be monochrome now. Anyway, the Northbridge VRM, the CPU Northbridge VRM, is just more of the same 40 amp dual end FETs from Texas Instruments. So that's just 2 more CSD 87350s. And that's capable of providing 20 amps while producing about 2.5 watts of heat. 30 amps while producing about 4 watts of heat, and 40 amps while producing about 5.5 watts of heat. So, plenty of power in the CPU NBVRM as well. Then for memory power, we're just looking at a single phase that actually looks like a single phase, which is let's put it this way. Modern Asrock motherboards will either literally have a real 2-phase or they'll have a single phase that tries very hard to look like a 2. Actually, it doesn't try very hard to look like a 2-phase. They just have 2 inductors and then a very obvious single phase layout of MOSFETs next to it. And it's just like, I don't like, well, the thing is most people don't realize that it's the MOSFETs that determine the phase, or like the controller and the MOSFETs that determines the phase count. So I guess it works for them, doesn't it? But anyway, this isn't like a single phase memory VRM. Now, I've said it before and I'll say it again. The memory power delivery really doesn't matter that much. Memory sticks don't pull that much current. Generally, what makes the biggest differences in terms of overclocking is the actual memory topology. And here we are just looking at a nice simple daisy chain layout, right? So you have your memory trace and you can see how it goes here, and then it just kind of goes on. And there's plenty of examples of that, right? Like this right here goes into there. So yeah, this is just a straight up daisy chain. Which you can actually get a lot of DDR3 motherboards with T topology. You can get a lot of AM3 Plus motherboards with T topology. I'm not sure which is best, but I do know that Well, I don't know what my Gigabyte board uses, but I do know that like the Asus 970 Aura I have absolutely hates some of the memory sticks I own. So and that's a T topology if I'm not mistaken. So I personally prefer the like, and I think the Gigabyte's a daisy chain. I'm not 100% sure about that though. So yeah, like it'll be interesting to see how this how this plays with my DDR3 memory collection. But basically what it does mean is that since it is a daisy chain, it's going to bias towards this DIMM slot and that DIMM slot. Asrock also advertises this as supporting DDR3 2450, which this is not an actual multiplier on the platform. The platform maxes out at 12x, right? Because again, the BCLK starts at 200. So I'm not a fan of this. Like that's literally not a multiplier. Asus has a bunch of BIOS profiles that set like 2600 megahertz, but it's just like, well, I'm not a fan of boards with, well, okay, having profiles is fine. Advertising 2450 support on a platform that literally doesn't have a 2450 multiplier is kind of, no. Like, that's just my outlook on it is just like, no, you don't have to do everybody one better when the platform literally doesn't do that. Like, yeah, so not really a fan of that. Like, it's not to say that this probably won't work. It's just that, like, you can't get an XMP memory kit with that. So it's just like, why even say that the board can do 2450 when realistically, if you're just buying kits, you can, like, at that point, you could just claim that, oh, look, we did 3 gigahertz on it once in a lab. And it's just like, yeah, I'm sure you did. It's not really that useful to the end, like, to the end customer, right? So anyway, but it is a daisy chain layout, and that's kind of that in terms of the memory section of the board. It'll be interesting to see how it performs. I'm not sure how many PCB layers this is on. I think it might be a 4, but it's really hard to tell, and I don't really, well, I guess, no, I don't think I'll, like, the thing is, like, you normally have to, like, I've not figured out a non-destructive method of figuring out how many layers a PCB has. I guess it wouldn't hurt too much if I screwed up the audio section, because apparently that doesn't work anyway, but I think I'll take a sacrificial board first to figure out how bad of an idea it is. But yeah, this could be a 6, it could be a 4. It's really hard to say because, like, the back looks a little bit like... This looks like the fact that we can see all of these traces makes me think it's a 4, because if it was a 6, I'd expect to have like a power plane, like power planes in this area. Not necessarily right here, right? I'd still probably expect to see, like, you could still probably see a lot of traces in this area anyway. But the fact that you can basically only see like the signal, like signaling for the VRM is just like, this is probably not that high. Like, this is probably a 4. So yeah, and also I think that actually we can see every single trace for the memory. So yeah, there's a pretty good chance this is a 4 layer, which not exactly confidence inspiring. At the same time, DDR3 really doesn't clock that high. So it's not as much of a, like, if you're at lower frequencies, the layer count just matters less because the signal integrity doesn't need to be as high. Anyway, let's talk about the Northbridge power delivery, and this stuff is a mess. And I say a mess because basically what we've got here is we've got some buck converters that convert 12 volts down to some intermediate voltage, and then we have, I'm not sure how many of them, but we have a lot of these large MOSFETs here that are just used as, I'm assuming they're just being used as linear voltage regulators to provide the Northbridge voltages. Also, this right here is also just being used as a linear regulator to provide the Northbridge voltages. So this could have some advantages, like the voltage regulation could actually be a bit better than having a bunch of separate, like, single-phase voltage regulators. At the same time, this is a really, like, the reason why you don't normally see, like, why most high-end motherboards, even for, like, low current rails, won't really, relatively low current rails, you won't see a bunch of linear regulators used, is because this is pretty inefficient. Because like, I'm not sure what the voltage they're stepping down from is, but let's say it was 1 point, like, they're stepping, the buck converter goes from 12 volts to 1.5 volts, and then they're stepping it down another 500 millivolts. Well, that 500 millivolts times whatever the current the Northbridge is pulling is power loss, right? Like if you have a 200 millivolt drop across your MOSFET here, and you're pushing 10 amps, that's 2 watts of heat being produced by your MOSFET, right? And like that's almost as much heat as this two-phase Northbridge VRM produces at 20 amps output. Like this is not a particularly efficient way of doing power delivery, but I guess as long as there isn't too much difference between all of the different, like all of the voltages in this area, right? They could be stepping down to something that's really quite close to the highest current rail, and then it's just like, yeah, it's not going to be that big a deal. There's a good chance that this part of the motherboard actually gets pretty hot because of the way that they're doing the voltage regulation, which is just like, yeah. And also, I don't think many motherboards do this. So this could have some interesting effects. Like it could lead to actually, like if it does translate into better voltage regulation, this could actually be better at Northbridge clocks and that kind of thing, or hypertransport clocks. At the same time, it could also have no advantage and just make the motherboard less efficient, which, you know, but both of those are possible. So it'll be interesting to see. So I'm kind of interested to see like how this behaves. Yeah, and I think that covers everything on this board. Like, basically, this is, you know, for a 990FX, if you're looking for 990FX overclocking motherboards, like, this is kind of the best you can hope for, unless you're, you know, committed to getting an actual crosshair, because the crosshair does come with some, you know, extra extreme overclocking features, like actual voltage read points and things like that, whereas this is basically like, here's a big freaking VRM, here's a postcode, here's power, here's reset, here's your socketed BIOS chip, and don't ask too many questions about how we're powering everything else, right? Like that's kind of the board here. So yeah, also the BIOS on this thing is terrible. Like this is one of those proper old Asrock BIOSes, and it's just like the thing I hated most about Asrock boards from this time period is that to select your CPU voltage, it's a freaking drop down menu. And it goes in 5 millivolt increments. So you're going to be scrolling from like, let's say you just reset the BIOS on LN2. You're going to be scrolling from like 1.2 volts or whatever the auto setting is to 1.8 in 5 millivolt increments. It's just like, oh no. But yeah. So I'm really not a fan of the BIOS on this thing. But at least in terms of hardware, this thing looks pretty solid. Oh, I forgot to mention. Yes, this right here. See this? Yeah, that is not okay. This actually, in general, is not okay. Like, compared to a lot of other AM3 Plus motherboards, Asrock has a, like, so it's interesting, because a lot of the other AM3 Plus motherboards that I've looked at, they'll go for a lot of 0805, 0805 package size capacitors. And they'll go for a little bit more of a fancy layout, which might have some benefits for the like parasitic inductance of the power plane. Whereas Asrock basically has a V-core island right down the center, right? So actually, no, it's like bleh. So they have an island of V-core right there. And then they decided that this bulk cap that was supposed to be here, yeah, they decided not to bother with that, which I find kind of interesting, because they basically opted for a bunch of 0603 multi-layer ceramics, which in theory should give it slightly better, like high frequency, like slightly better. I think these are better for higher frequencies, but than your 0805s, but it's not like a huge difference. But at the same time, it's just like, yeah. So I'm interested how this behaves. And I'm also kind of considering, well, there's a lot of empty space behind the socket, so I'm strongly considering adding a bunch of capacitors myself to see if I can't improve the voltage regulation of the motherboard. So, yeah, because at the same time, it's like, like the thing is, this is a chill voltage controller. It's not like, well, I don't know. Like, we'll see. Like, this is something like, the thing is, I do have a pretty decent collection of AM3 Plus boards, and I do actually want to keep adding motherboards to my AM3 Plus collection. So, one thing I am interested in doing is just, like, building a probinator for the AM3 Plus platform and probing a bunch of more motherboards and trying to see if I can improve them, because, well, more gigahertz is like the thing is with I wonder if it would make any difference to idle. If you actually made a difference to Because here's the thing, like one of the best things about the AM3 Plus platform is the 8 plus gigahertz CPU Z validations, right? That's, in my opinion, one of the most fun parts of the platform. And the thing about 8 plus gigahertz is you normally do it sitting idle on desktop, right? Like you don't actually run any load. You're just sitting on idle on desktop. So I guess I could do like a test with the oscilloscope to see how much of a transient taking a screenshot is, right? And how much of a transient saving the CPU Z validation file is. And then very specifically try to configure the capacitors on the back of the socket against that kind of loading. And that could be interesting because if I remember correctly from some of the motherboards I modified for my for the like Z390 and Z370 testing I did, idle was one of the places that I actually did get decent improvements in terms of transient response. So it's what like that the minimum voltage was actually going up a bit. It's just that like in day-to-day usage, you don't care about minimums at idle, right? Like who cares? It's idle. You're not doing anything. But on a platform like this, where, you know, one of the main things is like getting 8 gigahertz screenshots, it's just like, maybe there's a chance, right? There might be a chance to lead to make some significant improvements. In terms of the voltage regulation, very specifically for taking screenshots, which is just like, yeah. So that's kind of the other reason why I'm hoarding AM3 Plus motherboards is just like to test those kinds of silly things out, because it's a fun, like it's a cheap platform. This motherboard was actually really cheap because of all of the damage it had, right? Like I think it cost me like 50 quid total with shipping. So yeah, like, that's why I picked up the 990FX Extreme 9. It's just like, I need, well, high-end AM3 Plus board, it's got your postcode, got plenty of VRM, and we'll see what it does. It's also got a daisy chain, so it should be great for 2x2 memory configurations, which is kind of the norm of what you run for AM3. Like for DDR3 benchmarking, you normally run 2x2 anyway, because that's generally like the 2 gigabyte memory sticks tend to be the best for overclocking performance anyway. Like, so yeah. Anyway, that's it for the video. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, you can support me directly through Patreon, which is how I pay for, well, not that great purchasing decisions like this motherboard right here. Or you can support me by buying some AHOC merch from the AHOC Teespring store. There's shirts, there's stickers, there's posters, you know, the usual YouTube merch stuff. So you can find a link to that down in the description below as well. And that's it for the video. So thanks for watching. And yeah, like, share, subscribe, ring the bell button. And that's it for the video. So goodbye.